Today is 20th of April 2022, and we have um, a very exciting session today. We are into personal emergency management topic, and our speaker is very distinguished person. He works more quietly um than many of us have heard him. So he has been doing a lot of work at University of Chicago, University of Illinois at Urbana-Champaign, and Carnegie Mellon. These two universities, UIUC and Carnegie Mellon, are really the front runners in all computer and software technologies, and many standards are developed by these places. And he has Andrew John Dougherty, who is our speaker today, has released about 150 original code bases on GitHub, and most of it pertains to his um, his own formalized research database. It is called Fredska. I don't know how to pronounce, but it's formalized research database, cluster study and apply project. He has spent last 22 years developing this uh, research database, and he happened to have proven in his initial graduation days a corollary, and then he put some constraints on algorithm information theory on AI programs. Using that idea, he has further developed this FRD, CSA, logic, move, and many other meta projects with up to 150 members in each. He has worked with Psych, Emacs, Perl, and Prolog also. He has a custom markup by software and has tried to render that as a presentation today. We are very, very happy to welcome Andrew John Dougherty among us. And here is Andrew. Please feel free to share the screen and proceed with your talk. Thank you. Janet, welcome. Everybody welcome.
Thank you, Ravi. Is it okay if we transfer control to my screen?
Yes, it is already transferred. Everybody is allowed to share the screen, so please go ahead. I can see your photo logo. I mean, it's like a...
I'm trying to share audio now from the recording. Share sound, there it is. Okay, it should be ready to go. Can you all hear?
Not yet. I mean, we can hear you, but not the recording.
Personal Emergency Management Using the Free Life Planner by Andrew John Dougherty. Formalized Research Database, Cluster, Study and Apply, FRDCSA, Project. Ontology Summit 2022 Track 3, Environment Disasters April 20, 2022. This talk is in memory of my beloved sister Anne, whose tragic death when I was 10 years old drives to this day my unswerving commitment to the completion of this technology. Christina Taft's beloved mother, Victoria Taft, whose tragic death in the Paradise, California wildfire in 2018 drives her tireless commitment to emergency management technology. This talk concerns predicting, monitoring, mitigating and managing environmental disasters. Example environmental disasters: climate change, environmental pollution, wildfires, floods, habitat loss. I suggest what I, dryly, term a draconian solution, i.e. reducing the problem to a harder problem. As an analogy, I reduced the environmental disaster problem to general life planning, and put forth a satisfying implementation called the Free Life Planner aka FLP as a solution. And demonstrate how it applies in the specific case of handling environmental disasters. Preview of the Free Life Planner, FLP. Here are some, outdated, screenshots of services that the Free Life Planner provides. This talk is going to focus on this intelligent personal assistant which will help individuals to take control of every aspect of their lives, including but not limited to emergency preparedness. This video shows one temporal planning subsystem called Interactive Execution Monitor version 2, aka IEM2, which is part of the backend behind FLP. There is a corresponding web front end to this planning system. There are many dimensions to the problem of environmental disasters. In July of 2021, I wrote Al Gore regarding FLP, describing how one use case dealt with helping people to reduce their environmental footprint. The use case could be implemented via a particular kind of intelligent tutoring system, which elicits from the user all the relevant behaviors they engage in that affect their environmental footprint. FLP would then check whether or not these behaviors conform to local best practices in its rule base. When they do not, the system would attempt to act as an accountability partner to help keep them on track towards modifying their behaviors. A second example of an environmental disaster that could have been mitigated is the 2004 Indian Ocean earthquake and tsunami, which took over 200,000 lives. A cell phone warning system could have alerted and directed many more people to safety. This tragedy was disheartening because, although an idea is not an implementation, at that time I had been campaigning 2 years with no discernible progress for this system. 22 years on, although it hasn't yet made its impact, much technical progress on FLP fortunately has been made. In 2003, I wrote an article on general-purpose accident avoidance using psych and sensor networks. This article talked about using psych and KBS systems to make life-saving inferences. Although it describes a counterfactual scenario where a child using this system avoids being hit by a train, it bears strong resemblance to the problem of sending messages telling people within certain spatial regions to alter their behavior, such as to help move themselves, others nearby and loved ones to higher ground to avoid a tsunami. Or, moving to higher ground to avoid flash floods. The July 2021 floods in many European countries including Germany were an illustration of unprecedented weather saturating the emergency response coordination. These are a few examples of where FLP would be useful. However, being a life planner, it is intended to adequately manage many other situations and types of events. Here are some of the use cases for FLP. For positional reasoning, FLP currently integrates with the OwnTrack system, part of FLP's location logic subsystem. OwnTrack tracks users' location via cell phone and is free Libre software. The FLP GitHub pages list many of its current subsystems, which are in various states of completion. I will now focus on how to create free Libre's social-friendly artificial intelligence in service of the problems of day-to-day living, including planning and behavior modification, and also emergencies, through emergency preparedness and emergency management. This can be achieved through systems integration and software applications of knowledge-based systems. There is a need for an intelligent personal assistant which is with the user in the trenches, enabling the last-mile delivery of salient guidance, and conversely uploading evidence for public health. FLP is intended to, eventually always, meet this need. FLP is a mobile-friendly web application, which plans preactively, proactively and reactively, at multiple levels of granularity, in order to both survive and thrive on a daily basis, and prepare for managing emergencies when necessary. The purpose of the talk is threefold. First, to illustrate that because free Libre software is freely redistributable and can assist people indirectly, whether or not they have a computer, it has the potential to offer help to almost everyone on the planet, in the same way that GNU Linux could. Second, to convince you that FLP could in fact help save lives, improve quality of life, and reduce intense suffering. Third, to enlist your active support of these projects. Some disclaimers. And some suggestions. There is more relevant information than I am able to summarize contained in this presentation, so I recommend re-watching the video and occasionally pausing it as needed. Outline of the talk. This video by Paul Fierro shows his excellent simulation of a counterfactual evacuation of Paradise, California from the Camp Fire that started on November 8, 2018. One way to frame the problem of emergency management focuses on the global, third-person, top-down, macro perspective. Another way to frame the problem is to focus on the local, first-person, bottom-up, micro perspective. This can be achieved, for instance, via a mobile hands-free plan monitoring application, such as the one I developed shown here.
Open door.
Failed.
Unlock door.
Failed.
I use a fisheye lens here as a metaphor for this first-person perspective. FLP operates from this individual perspective, which may be federated to form a community, and thus focuses on the community perspective as well. Originally, I was to give a presentation on the pandemic track regarding my COVID-19 behavior tree paper that recommended developing a prologue-based plan monitoring system, but fell short of fully implementing one. The plan monitoring system was conceived to help overcome the last-mile delivery of efficacious knowledge and procedures for reducing the spread of and mitigating the effect of COVID-19. Unfortunately, this paper, written at the very beginning of the pandemic, really missed the mark. I had not predicted that a sizable percentage of the population would not be willing to adhere to guidelines for measures like wearing masks or being vaccinated. Any successful disaster management strategy must therefore account for the human factors present. Nevertheless, finishing the original Plan Monitor would still be of specific use to those who need extra layers of security during the pandemic, for instance the immunocompromised and their associates. As well, Plan Monitor is of general use for interactively walking users through plans. So I persisted and ultimately developed a Perl-based Plan Monitor system, in addition to the unfinished Prologue-based system, which can be installed using the commands shown, but which did not depend on any unreleased FRDCSA code. Thus, Plan Monitor is a mobile-friendly web UI for walking users through tasks such as going to the doctor, the grocery, receiving mail, etc. Here it is in operation. Some important features shown here includes the ability to branch on plan failure and hands-free operation.
Door.
Fail.
Smash door.
Done.
Walk through door.
Done.
Close door.
Done.
Plan Monitor has many strengths. However, Plan Monitor also had some major limitations. After asking the AI planning community, there appear to be few options for an open-source system like Plan Monitor that can handle temporal, concurrent plans. So I intend to fork Plan Monitor and extend it to handle temporal concurrent plans via behavior trees, as a front end, and handle the back end and merging of the concurrent plans using the previously mentioned Interactive Execution Monitor v2, IEM2, more of which will be shown later. Here is an example taken from my COVID-19 paper. However, the Prologue-based behavior tree software that evaluates this particular behavior tree has not yet been fully completed. For the time being, I've taken a shortcut which will hopefully be backwards compatible. This shortcut is to switch to using the JSON Belief Desire Intention, BDI, agent architecture. This is what the code from the earlier slide probably looks like in JSON agent speak. Fortunately, JSON agent speak appear to implement a superset of the features I was able to implement in the behavior tree software I wrote. It is also much more mature and popular. Here is one possible mapping from behavior trees to JSON agent speak. The default intention handling code for the JSON agent speak BDI architecture event loop operates in a round-robin fashion, and is thus FIFO workflow. This helps to avoid dropping the ball, as happens with a LIFO workflow. Because JSON is based on Prologue interlingua, I have since integrated JSON with SWI Prologue. I intend to use JSON SWI Prologue as the metaplanner to control other, PDDL etc., planners through FLP's planning wrappers. Metaplanning could eventually be achieved through integrating LogicMu, OpenPsych, JSON and SWI Prologue. Another tool mentioned in my COVID-19 paper is the Shared Priority System Editor version 2, or SPSE2 system. This tool proved personally useful during the pandemic. I often developed 50 to 100 point temporal plans for the accomplishment of tasks rendered more risky due to the pandemic. SPSE2 was a predecessor of, and now a component of, the Free Life Planner. Because of a family emergency, I had to withdraw my Ontology 2022 pandemic track talk. However, I had already written some of a paper which was targeted towards general threat management. I am now presenting in the Ontology 2022 Environment Disasters track, but this is just as well, since the overarching tool this presentation is about, the Free Life Planner, subsumes both use cases. I wrote this paper in order to talk more about threat management. This paper will be finished and released some time after the presentation. In a game-theoretic formulation of real-world security protocols, it is possible to try to treat the world as a game, and then win that game by proving that bad things don't happen to people. Yet, the cardinality of possible moves is so large that the branching factor dominates, rendering deeper searches ineffectual, except in restricted subdomains. This suggests a knowledge-based approach towards inventorying and categorizing threats. From the upcoming Predicting, Monitoring, Mitigating and Managing Threats paper. Our system for managing threats to security is called Whopper, after the contingent planning computer in the movie War Games. Through Whopper and other systems, FLP is intended to help bolster every type of security. So, if Isa, Andrew Dougherty, person, were in the Whopper prologue factbase, the prologue code declares a contingency plan needs to be developed for the possibility that I became infected with COVID-19, and suggests that I should quarantine. The next step is to develop the hypothetical contingency plan for me quarantining. In order to develop contingency plans such as the quarantine plan, we must deal with the reality that the life planning environment is dynamic, uncertain, incomplete, underspecified, etc. Thus, it is difficult to completely represent future states in which fluents like infected might hold. One system which can handle such environments is the General Flux Cognitive Agent Programming System. Flux has many advantages. We did implement about 10 different planning domains in Flux. However, I had some difficulties when using Flux for this purpose. Because of these difficulties, I was unable to proceed until I rediscovered the JSON Agent Speak system, which is designed precisely to handle dynamic, uncertain environments. Whopper is able to generate requests for the creation of plans for these contingencies, which are then implemented as plans inside JSON Agent Speak. And then the JSON SWY prologue plan is selected and executed. Some open questions. How do I handle time or model the environment? This is the beginning of a threat ontology for Whopper. Any threat knowledge base that I could piece together for this talk would be incomplete, since I haven't done enough natural language processing. This is merely intended to be evocative of the kinds of threats that should be included, and how FLP will deliver on these counts. We could work on both preparations and appropriate responses ordered by some norm on likelihood and impact. My AI has been from the outset intended to improve survivability while minimizing intense suffering. These are good goals when considering prepping and survivalism. To partially achieve this, we rely on preparations. These kinds of checklists are a start, but better as a persistent assistant which guides the user to achieve and stay on top of emergency preparedness. Here the system would schedule a task to remind the user to check their fire alarm batteries 6 months after the last time they checked. Here is a recurrence specification to remind the user to inspect their food and water supplies once a month, provided they are obligated to maintain them. This survivalism use case story details how FLP is intended to work. It is definitely worth the read. Many people, including some computer scientists, did not really understand FLP or FRDCSA until reading this document. This is another use case story, detailing the healthcare component. I cannot in general show the full boot sequence of FLP because of private information, since I am dogfooding the application, i.e. using the program while writing it. This is a good time to talk about FLP's usage of what I call the prologue psych discipline. Prologue psych discipline means to me effectively following the protocols, APIs, vocabularies, etc. that tools like OpenPsych have established. Here is a concept from the outdoor survivalism literature. What this rule is attempting to say is that, if a person eats lean meat, and does not eat anything fatty along with it, it's possible that they will develop protein poisoning. The idea here is to use these kinds of rules as world knowledge to constrain plans. However, since translating this rule to prologue psych, I have learned that this concept about eating lean meat being potentially harmful is itself not necessarily correct. I will talk later about rule provenance and trust management. FLP has limited KBS support at present. However, it will be much better once extended, and or integrated with LogicMu and or OpenPsych. A major strength of FLP is that so-called rules governing life can eventually be mined from natural language. Here is a sample PDDL plan to tackle a homelessness scenario. PDDL is an extremely powerful planning language, which I use throughout FLP and FRDCSA, however it has some limitations. Please note there are probably exceptions to some of these cited limitations. Since most PDDL planners do not seem to allow one to change the domain or problem specifications at runtime, with the exception of Andrew Gree's metaplanner, we return to the subject of metaplanning. In order to define metaplanning, I refer to this sample document written by Douglas Miles which describes what is intended by the term. The TAEB planar AI makes heavy use of metaplanning and pathfinding for the video game called NetHack. There is for instance a higher than expected degree of similarity between playing this game well and surviving emergencies such as environmental disasters or homelessness. Both problems are roughly speaking survival-oriented pathfinding. I therefore rehabilitated the TAEB planar AI in order to attempt to make use of its code for application to this real-life survival planning. This article goes into great depth about how TAEB planar's pathfinding works. It is very enlightening. However, I was not able to properly harness TAEB planar. I have had more success with metaplanning by focusing on JSON SWY Prolog. Here are some of the contemplated use cases for metaplanning with our autonomous JSON SWY Prolog software. A major goal of FLP is helping people avoid or get out of proximity to traps, since it is easier to get into a trap than it is to get out. I want to make very clear that this project aims to help everyone, not just the marginalized. Having said that, there is a current focus on problems affecting the marginalized, since they are more exposed to more problems, such as the COVID-19 pandemic, and increasingly frequent and destructive natural disasters due to climate change. Moreover, free Libre software inherently has more potential to reach the marginalized and adapt to their conditions in ways that proprietary software cannot. There are around 125 released FRDCSA systems on GitHub. Here are a few ones related to this presentation. We need to do a rewrite of FLP once LogicMu is ready, as there are just too many issues with the present FLP codebase. Defining FLP project success. Releasing FLP and FRDCSA has been the Achilles heel of the project, because of difficulty redacting private information, writing the installer, learning the packaging mechanisms, hardware failures, and many other issues. The Formalized Research Database, Cluster, Study and Apply project. The project logo blends the F from FRDCSA, the satisfaction relation, and the Greek letter phi, made by altering the Debian project logo. Phi here denotes a set of sentences representing problems or constraints. The FRDCSA project logo is intended to suggest that the FRDCSA can correctly solve life problems, through extension of the Debian Universal Operating System with additional, usually AI, packages. I want to create an increasingly powerful, weak AI. There are many ontology and knowledge base projects in some state of development in FRDCSA. FRDCSA project is more fully specified by its many goals. There have been many mistakes committed. Releasing FRDCSA. Just recently, some interested collaborators have helped to motivate and push me to fast-track the FRDCSA Panoply release. We've decided to make the outdated and redacted Panoply Git codebases at https://github.com indless the stable, only branch of FRDCSA. I will then backport as much as feasible from my private version, which I've written these last 5 years. This means that a working version of FRDCSA is now installable and live, i.e. no longer a terminal branch of the project. Do note, although the installer is released, it's not ready yet. It should be ready soon after this presentation. Moreover, it needs some files to be sourced properly. Some stuff that has got in FRDCSA the most attention took a couple hours, like the project's robotic book scanner. On the other hand, FRDCSA has taken 22 years. It will be a game changer now that the system can be installed, and people will see what FRDCSA can do. AI really needs a first-class effort like the Manhattan Project, or the Apollo Project, to inaugurate AI. Perhaps I'm describing the Psych Project. I admire the technical achievements of the Psych Project. The purpose of the FRD project is to create a universal database of all mathematical knowledge. For instance, focused crawling and packaging all the software systems referenced by swmath.org. CSA includes non-mathematical software systems. We are attempting to collect algorithmic solutions to as many computational problems as we can. Thus, our software archive contains solutions to large numbers of computational problems. The problems that people routinely face are usually reducible to these computational problems. There are more kinds of computational problems, however, than just decision problems, as mentioned at this URL. The FRDCSA theses, combined, say that it is imperative to collect and package free Libre open source software en masse. This is an early and partially incorrect write-up of the deductive part of the FRDCSA thesis. But the statement of the results I believe to be correct. Part 1a of the FRDCSA thesis says that for any program there is always a larger and stronger program. By larger I mean greater Kolmogorov complexity, and stronger I mean proves exactly a strict superset of true theorems. I like to think of this result as saying, there's always a bigger fish. Part 1b of the FRDCSA thesis says that it is not the case that for any program there is always a stronger program that is however not larger. This essentially means programs must ultimately grow in order to solve more problems. Mechanization of the corrected statement of assumptions and proofs for parts 1a and 1b of the FRDCSA thesis has been started by Stoop Kid and is available here. Can't say I've found anything that I'd call a defect in your theory. Of course, there were minor details in your original formulation of the logical statements that had to be sorted out. But even though my AGDA formalization isn't quite 100% yet, I have no doubt at this point that the assertions about the necessity of aggregation are true, mathematically. On the other hand, what to actually do with that information in practice is something I'm rather less confident about. Stoop Kid. The part 1a and 1b follow from the fact that no program can decide the truth values of all statements in an undecidable logic. This AGDA proof seems complicated to me, but the intuition is simple. For part 1a, since no program can decide all, that means that there are always more decisions that can be added to the initial program. For part 1b, the issue is that the programs must eventually become larger, since for any given program there are only a finite number of smaller programs, but there are infinite sequences of increasingly strong programs. Part 2a of the FRDCSA thesis is abductive, and says that one way to increase program strength is to collect software, in lieu of a better approach. Here is a first try to formalize this. FRDCSA, Thesis, Part 2b. Abductive. Given the extent of free software, packaging this software is a necessary step of any practical attempt by our group to increase our solution space. There are many benefits to packaging software. FRDCSA, Thesis, Part 2c. Deductive. Collecting software is not sufficient, therefore we must write numerous systems to help us glue the functionality of the software together where necessary. I have written over 900 codebases. However, some of them are mere stub projects, containing, for instance, notes on how to proceed. This paper by Gregory Chaitin expresses the idea particularly clearly. The approach of this paper, in contrast, is to measure the power of a set of axioms, to measure the information that it contains. We shall see that there are circumstances in which one only gets out of a set of axioms what one puts in, and in which it is possible to reason in the following manner. If a set of theorems constitutes t bits of information, and a set of axioms contains less than t bits of information, then it is impossible to deduce these theorems from these axioms. Simply replace theorems with problems, axioms with programs, and deduce with solve to understand the general necessity of having more software. i.e., if a set of problems constitutes t bits of information, and a set of programs contains less than t bits of information, then it is impossible to solve these problems from these programs. What is the channel capacity of one human programmer typist for meaningful information versus millions of programmers? We must therefore rely on the work of others, in order to address the algorithmic information bottleneck. The project theses leave open the question of how fast program size should be increasing. I need to formalize this answer. We can't outrun this bear. True, but I can outrun you. There is an alarming lack of packaged artificial intelligence software. This example shows how the search phrase, artificial intelligence, has but 4 matches out of 60,000 Debian packages. People on the Debian channels ask, well, what AI systems would you package? For starters, I have semi-automatically collected over 2,000 free Libre open-source AI systems, and maintain a prioritized list of software to make into packages. Engineering the FRDCSA can be likened to creating a toolshop, with the intuition that it is provident to collect and prepare tools for use before problems are encountered, thus sparing the possible failure of a last-minute search for the proper tool under time pressure. I have begun argument mapping various debates surrounding the FRDCSA and FLP projects, in order to precisely characterize them, and hopefully generate arguments and proofs that support the goals and strategies of the project. These arguments could hopefully be used to help persuade rational people to support the project in any way they can. Acknowledgements. Thanks to D. Miles, CASAM, J. Ballint, Q5, Stoopkid, Justin Kosler, Christina Taft, Meredith McGann, Paul Fierro, Dr. Ravi Sharma. The end.
Well, that's the entire presentation. Well,
Thank you, Andrew. That was really a very intense presentation. Did you send
Yes,
that to us?
Thank you, Ken, for starting. I'm sorry, I was muted and speaking. Go ahead, Ken.
Can you give us, send us that presentation so I can post it?
yeah, it's in the chat room, the Ontology Summit 2022 room.
Oh, okay.
You mean the 2 links that you just posted, or one link? One link.
It's the presentation.txt file
Yeah,
from GitHub. Okay.
very good.
Yeah.
Is that, if we click on that, will we get the presentation that we just saw?
No, I can provide the URL to the video. 1 second.
I didn't know that Cass and you were also involved. Cass was involved in the part of the project. That's very good. And I didn't do anything except to encourage you and invited you to come and speak to us. There are so many elements to your talk. Unless others have questions, I would like to ask you some. Thank you for posting that video too. Video link, MP4 link. I will try and copy these and send them to Ken, and Ken can also capture that so that we have it as part of our summit dialogue. Can I go ahead and ask questions, Ken?
So go ahead, Ronnie.
There are several elements I can see. I'm not a coding person. I'm not a programming person. I am a theoretical physicist. So I have done some coding in the past, but not at the current GitHub level. To make the story short, 3-4 elements I see. I see knowledge bases, which may have underpinnings in databases, but you seem to have aggregated pure data into some aggregates of information elements. then you are apparently going and collecting what is needed from them through some kind of AI-based filtering, which gives you results for what is relevant. For example, if it's a fire situation or flood situation, only those relevant parameters are presented. Then I kind of lost as to how you marry or merge these things with the micro theories and come out with a personal assistant that can help you in emergency management. So can you kindly elaborate a little bit on that?
Well, so I index project features using natural language processing, and I've written something called System Recommender, which you can list some files with text describing your problem, and it searches through like the Flossmole Data Mart and GH Torrent and finds related software. So that's one approach. There's a system called the Architect, which is responsible for tracking use cases and applications of the software, and then it tries to matchmake with the software it's able to find. So generally, what happens is I expose, I download systems and systems that have the capabilities that are most or pressing, and I package those and then I expose them their functionality through APIs to the rest of the system. And so and let me think 1 second, please. So I use these different capabilities to do the life planning, and that's where there's other systems that I've written, like the planning systems that I've showed you. Those are more specifically suited to the pathfinding for life planning, but it's there's I track different APIs for API mashups online, like Google Earth and some other navigation software systems, and combine that with the OwnTrack system for location awareness. So that's just a general sort of picture of the approach.
So for example, if I were stuck in a flooding situation, would you be able to use contouring or other techniques to allow me to escape to the most optimum route to a higher level where I have less chance of drowning?
Don't have anything like that, but that would be a nice feature to add. Mainly what I'm working on is the preparation aspect, so people are prepared. And I don't have the psych system that I mentioned for general purpose disaster or collision, or emergency locational logic. That's not fully functional at the moment.
And I hope you remember that Doug Lannett has said that he'd be open to go to the current, or allow the collaboration or access to his current psych system rather than the old open source. But even the current one, he would allow people to collaborate. So that will have more enhanced features, just FYI from his talk.
Well, that's awesome, because I really look up to Doug Lannett. He's done amazing things with Eurisco and AM and Psych, and without his technologies that we use as a basis, it'd be a lot harder to integrate these different systems. His Psych is I think Doug Miles puts it as a maybe a blackboard that is specializes in systems integration.
Doug, you are there. Cass, you are there. And Asia, anybody has questions, please chime in. I have a lot of questions, but that's out of ignorance. But you people know the field a little bit.
So something that I've been pretty impressed with, Andrew, I've been able sometimes to see the editor that you've been doing for Fredska. I know you had it some on your slides, but the some of the I'm not sure how much is redacted that you could show off again of the Free Life Planner, but it was a really nice interface. If you had more screenshots or something, that would be super useful
Yeah,
to people, I think.
yeah. The redaction is stymieing the distribution because I don't have it's difficult to take pictures of stuff that you're using every day with personal information. So I will definitely make some screenshots available after the talk. And I wanted to add that we're releasing the entire system very shortly now. We have an older release which was fully redacted, but that lacks most of the modern features of the Free Life Planner. But I'd say within we're fixing the installer within about 2 weeks. It should be installable, the original release. And then over the course of the next several months, I'm going to be redacting all of the modern progress by taking a diff of the redacted ones with it's hard for me to remember, but basically I only have to redact the differentials between what's already been redacted and what additional growth there's been in the intervening years.
This, sorry to butt in, but is this reduction just to remove personal information or much more than that?
It's mainly personal information like medical information because it was I used it in a caregiving capacity because there's a medical health planning system. I think I included the link to that in the presentation, the health planner. So yeah, it's mainly just owing to the way I developed the software. I never was able to release it, and it's just accrued all kinds of personal information that isn't really fit for release. So, but I did redact on GitHub. There's about 125 code bases, and the installer that I'm releasing is going to be able to download those from GitHub and integrate them and have a running version. And there's a virtual machine version if anyone is interested in that already runs, which does this. But and you can find that from Vagrant. I think it's called Vagrant. I'll look it up real quick. I'll include the link after the talk. It's a already installable VM of the 5-year-old release.
Very good, very good. So that's a standalone simulation system one can use.
Yeah, and Doug has LogicMoo, and that system is operating at a higher level than the Life Planner is right now. And when LogicMoo is operational, I'm going to be relying heavily on like the event calculus representations and everything that Doug has been working on. So a shout out to Doug and Cass there.
Fantastic,
Yeah.
fantastic.
Yeah.
What a wonderful example of two of our regular visitors to or participants to this forum and summit that have been collaborating, and we didn't know. So it's nice to know it here. Some thoughts on ontologies, how they are embedded already, or how to extract them out of your such enormous work? Or is it just because the micro theories are being used that ontologies are implied?
Well, I have a lot of predicates that are roughly patterned off of Psych. The goal is eventually to be integrating with Psych completely. In Prolog, you don't have to define your constants before using them, and there's a lot of other things that kind of accelerate development. So I'll be definitely grounding in the Psych ontology and using natural language processing. There's a link to some stuff I did using KNext for extracting out implicit information from natural language that helps build the kinds of ontologies that, or knowledge base, I should say, I work more on the knowledge base side of things, less on the ontology.
Mm-hmm. Thank you.
Thanks.
So that clearly shows the ontology connection.
Yeah, it's interesting how much psych has created a way that programmers can. Well, so when you're writing in psych, really was great for programming and has so many features that I wish was more used by everybody out there in the world. Because if you are interested, if you're knowledgeable about ontologies and you're a programmer, I find it's a lot easier to use Prolog or something, but very difficult to use Java or JavaScript to really interact with your ontology and data. So I guess where I was going at is that, yeah, Prolog has this advantage of not making you separate your program and like the functionality that you're going to want to see from the ontology. So, I mean, you can sort of define the type of work you want to do in your daily code in Prolog. And I wish there was, but anyway, I know where I was going. Psych-L is a lot like Prolog, except without some of the problems that people associate to Prolog, like infinite looping and all the things people dislike and complain about Prolog. Psych-L really solves those problems. Psych solves that problem. And it sure would be nice if it was out there more usable for the whole world. And because like Nancy Weingarten's a great example when she was showing us the stuff that she's able to do with showing us frames inside of RDF, but you know, sometimes those things are pushed away from where the programmer can access them. But I was impressed with how much was being done in RDF and OWL, or in the ability to show off frames and so forth.
And Nancy, you have comments? Janet, you have comments on what Doug just said or what Andrew said?
Would be interesting is like what Nancy showed, I think it wasn't last year. Anyway, it blew my mind how much like useful RDF and how comfortable it looked. But I felt like that must be the exception, not the rule.
Mm-hmm.
But you know, if Nancy saw other people doing the same types of things that she was, I would be really impressed to hear that. That would be nice. I mean, yeah.
So how far away are we from what you are going to release, Andrew? And where would it be usable?
Could you repeat the question?
How far you are releasing some version which would be useful, and you also have a VM where people can simulate.
Oh yeah.
But something for the public to use in the personal emergency management sense, downloadable on their smartphones or computers, and at least rehearsing, what if I get a flood? What if I am in a fire?
Yeah,
That
well,
kind of-
this is not quite at the last mile there. It needs to you know, it's capable of being run as a public service, but you would need DevOps and probably some corporate sponsorship of it. And then to be used at an individual level, it's still, I would say, a ways off, especially the planning component, because of the difficulty of modeling real world planning in PDDL and these other languages. It's getting it to scale up. I did show the homeless example, and homelessness is one of the areas that I'm most interested in. Simply because planning for logistics, also, you know, low income environments, it's the logistics tends to dominate, and I think that the life planner would be more easily deployable in that kind of situation than for instance, the floods yet. So, but it's definitely like an apparatus that could be extended further, and that's kind of the point of making it public.
So like you had something like the meal planner. I don't know if you didn't mention that just now, but that was pretty solid. But then you're competing against other like entire companies that are doing meal planning for people, but you would want to be able to integrate that, right?
Yeah, yeah. The meal planner is an example of something that helps you know, stretch the dollar and improve health at the same time. It freezer cooking, for instance, is something that reduces preparation time and expenditure about 4 times. So helping people to plan out their meals in advance and to cook them, you know, at scale and freeze them, you know, things like that. So the meal planner is definitely a high priority. I'm just trying to apply artificial intelligence planning to daily life. That's the gist of it.
Wonderful. These are certainly aiming at the right section of the society which needs more help. But I'm wondering at the same time how savvy are, for example, the community in homeless situation be in ability to use these applications.
Well, I have a URL which shows that about 70% in one study of Americans who were homeless had a cell phone. And
Wow.
but also the software is able to, will be able to be used by institutions that are helping the homeless. So it doesn't have to be in their hands to benefit them.
Mhm. Yes.
But ideally it would be there's the homeless story.html I linked to, or I can link well, it's in the slides. I'll link to it though. That's a very good example of a use case which would demonstrate how ideally this system should function. It's kind of difficult to write it myself, but hopefully there's been a lot of interest from like Koo and Stoop Kid about releasing the system. So we're getting it released and we're already developing a team workflow. So
Fantastic. Thank you. Very, very good.
Janet and Alex have some comments on the chat room.
Yeah, hi, thanks. I wanted to commend 2 aspects of the way you're approaching things that I think are really important and should be, you know, codified as principles for ontology development or ontology use. The way you said you tackled the problem by reducing it to a harder problem, or putting it into a broader context so you can actually understand, you know, operationally what all the, you know, the systems aspects are that come in. I think that's really key. And it's so rare to see that because, you know, commercially people tend to just take a slice of something and attack it rather than putting it into context the way you're doing. And then the fact that it's all driven by actual production of value in the lives of the users is also something that is sort of, you know, implicit but rarely brought out to the extent that you're doing it. So I think this is exemplary on those 2 counts. Wanted to appreciate that and bring it out explicitly. Thanks.
thank you. I really appreciate that.
Alex had a question.
Oh, right.
Yeah, just as I put it into the chat, that
Well, regarding Wolfram Mathematica, it, you know, that's a great system, and so we're working on, you know, there's Sage Math and some other open source systems that implement, you know, or try to re-implement Wolfram Mathematica, and so I have those, and with swmath.org, there's about 35,000 systems. And so, just the first step is making them available on the system itself, the distribution like Debian. And then from there, you can work to integrate them further. So yeah, we have a Mathematica replacement as part of the project. It's called, I think it's called MegaMath, but I haven't been working on that recently because my collaborator Michael Holtis has been busy.
So would you use the logic or math from Wolfram?
Well, I don't have an API to Mathematica, but that would be a good idea. I'm trying to keep the systems open source so that there's frictionless redistribution. But yeah, Psych is proprietary, and so it does interface with that. So I definitely should have a Mathematica backend. But the idea is with formal theorem proving, to characterize the situation in a theorem proving context, like with TP, THF, and all these domains. And hopefully, I'm not very expert with the math, but I think it's in some sense the problems are reducible, at least decision problems, to interactive and automated theorem proving.
Thank you.
Andrew, may I say just one point? My first point is to compare these two great projects, yours and Wolfram Mathematica, because you concentrate a lot of mathematical knowledge. This is the idea. Is that a right point?
Thank you.
Sometime we've got to see how much Mathematica is doing ontologically. I mean, like, I know it's a great mathematical system, has it has theorem proving, but I wonder how much would be translatable to the types of inferences that we care about in, ontology building and so forth. If Mathematica has, well, Wolfram Alpha, I suppose, has put much work into working with some of these formal languages. It almost need to have some of that so these things would be comparable, easier to compare to what Fredska's doing.
Yeah, about Mathematica, I noticed that the last time I checked, I asked it what the runtime of Quicksort was in its natural language interface, and it didn't have an answer to that. So, there's complexity zoo and other sources of mathematical knowledge. So one aspect of the project, Fritzka, is sorry, I lost my train of thought, is adding those types of answers to the Psych system. So we have a mathematical knowledge management project, and ideally we use Psych to accomplish the translation between the formal mathematics and the more like story problem side of mathematics, where you're trying to take a problem and translate it via common sense into a math problem. So it'd definitely be useful if there was, RKF type rapid knowledge formation, acceleration of building large knowledge bases, which have these kinds of answers. Like, for instance, I mentioned the runtime or the complexity of Quicksort, and that's useful for program composition and synthesis. And I think a lot of the life planner, if when it's doing what it's supposed to, it'll use program synthesis. There's also a lot of new neural methods for program synthesis, so you can generate and check, generate with neural and check with symbolic reasoning. So that's my thoughts on Mathematica.
Excellent. I have worked a little bit with knowledge management systems and knowledge bases in the DoD type context, but the difficulty I found often was in reuse, because the situational situation around use of the use cases differed. So when we were trying to reuse, we found that we did not have enough intelligence to determine whether it can be reused or not. But now with the advances of AI, it should be possible to match with situational knowledge. Just a comment.
Thanks. That reminds me of a graph, subgraph isomorphism problem that I think I heard Kindy solved in n log n. Is that right, Doug?
I had not heard that, but that's interesting.
Yeah, I'm not I'm not expert in this. I just remember hearing that fact.
Knowledge reuse from knowledge bases. There are a lot of elements you showed today that I see the connection, but not being so technical in the use of code. But I see a lot of elements that you do. You use obviously the psych, and now there is suggestion from Alex on mathematics, from Wolfram. So, and then your efforts and Doug's and Cass's. I mean, it's amazing how integration of different collaborators works can bring more value. That I see.
Yeah, thanks to Doug and Cass and everyone else. I'm ontology is not my specialty. I'd say I'm more of a systems integrator.
Great work. Thank you for sharing with us. And any more questions? Ken? Anyone else?
Yeah, it seems that you've taken care of all the questions, and so just thank you very much. This was a fascinating talk, and hope to interact with you more on the forum and the summit in the future.
Yes, definitely.
Next week on the summit,
Julia Barrett?
we have Julia Barrett, Barbara Regania, and Serko Schindler. So that's a panel, I believe, on climate.
Yes. And Gary is not with us, but Gary is coordinating that.
Gary Burkross will be coordinating it. So hope to see everybody next week for the last session of the Environment Disasters Track.
Thank you.
Wonderful. Thank you very much.